Hello, Professor.
How are you, Mohammed? How are you, Maricel?
Good afternoon.
Hi, only three people, huh? Ah, well, we are like 3 minutes past the hour. It's not like we're too early. We're on time. Where's the rest of everybody? I can, okay. It looks like we have only like how many? One, two, three, four, five, six in the discussion board, and only three here in the so okay, Jennifer is joining, so four. So it's all righty. How are you, Jennifer? Finally, you're back. Now, looks like yeah, we have still more people to join, but let's see. Let's just uh, let's give them a couple of more minutes. But while we're gonna get started and without any further delay. So let me just okay, today's sure today's thing. Okay, I'm doing the screen sharing now. Oh, so it was. Oh, what am I doing? Okay, let's search. That is weird. How can that be? There you go. All right. So so we were talking about the last thing we were talking about was the APY, right? Effective interest rate. And to we need also let me also open this file. Where is this thing? So we had to take a look at uh, the properties of exponents, right? That was the last thing we did. And if you, I hope this would be enough to jostle your memory. I can't, reteach everything, and you gotta study to remember. And if you don't remember, if you can't remember, then I'm sorry, it's your responsibility. As a student, you have to, study and retain this in your memory. So, in a word, when I defined effective interest rate, I said that is, think about it, 6% interest rate compounded just once a year, uh, will get you to this 5 years later. I mean, 1 year, 5 years later. They are, right? But if it is compounded twice a year, this will be the future value. If it is compounded quarterly or 4 times a year, this is the future value. If 6% is compounded monthly, this will be the future value. And so you can tell, we already know that the higher the compounding frequency, the greater the future value, right? And then our question is then, so although APR is all 6%, all the same, but actually the results are different, future values are different because of compounding, because of the frequency of compounding. And then one question arises. So if daily compounding daily compounding, right? If we get to this future value, right? And certainly 6% won't get you to this future value, right? Compounded annually, right? If compounded annually, it's not going to get you to this, it's going to get you to this. So what kind of rate will get you to this? Compounded just once a year, right? Compounded just annually. What kind of interest rate will get you to this future value, right? 5 years later. Okay, so that is the definition of effective interest rate. Let me see how hasn't changed. Christopher is here, but other than that, so everyone understands the concept of effective interest rate. Obviously, effective interest rate will be different from the stated or quoted interest rate. This APR is stated or quoted because that's exactly, okay, let me type it in here. Okay. It's quoted or stated by the bank, right? So that's why it is called, okay. Okay, that's called the stated or quoted rate. This isn't very pretty, but okay. So APY is different from, that doesn't look nice. Okay, so everybody understands why. Then how do we find effective rate? In other words, what kind of interest rate what kind of, APR, or what kind of stated or quoted rate will take you to, will take this 1,000 to this future value, compounded just once a year, right? So the formula for uh, APY, or effective interest rate, is and I gave you all the materials to study. You see, this was already given to you, and it's in the lecture notes folder. You should open it and you should study it, right? You should. I put it actually at the end. So now, if you take a look at this effective interest rate, this isn't that this isn't that strange. I mean, this is not that unfamiliar. This is something you already know, right? Why? What is that? This is actually, if you look at only APR over M, that is basically a pure how you find a periodic rate, isn't it right? That's how you find the periodic rate. It's making adjustment. You're making adjustment to APR for the compounding frequency, right? So, but we don't, because we are trying to find just 1 year rate. We don't need T times M, because it's just for 1 year. Therefore, it is simply, I'm going to write it out here first. Before I do that, let me write it out here. And then APY 1 plus APR over M raised to M minus 1. Some people wonder, why minus 1? Well, it's simply because you want to, think about it. If you don't subtract 1, it will be including this 1. It's to just to get the net return, right? In other words, when we say interest rate is 10%, we just say interest rate is 10%. We don't say it's 110%. Obviously, because 110% is what? That is gross rate. I mean, if you put your money, if you put your $10,000 in a bank, if you put your $10,000 in the bank at 10% interest rate, 1 year later, you will have, of course, $11,000, right? Because interest rate is 10%. So interest alone is 1,000, right? 11,000 is not the interest. 11,000 is the future value. That's the result of the 1 plus R, right? So we want to only isolate R. So what do? You'll have to subtract 1, right? So following that, so everyone has this file opened in front of you, everyone? Yeah, I can't see you. I can't. Okay, let me. Everyone has this file in front of you. Okay, Monique, do you have something to say, or did you just express that you have that file?
Yes, I just responded to your question. That's all.
Oh, you have it in front of you. That's what you wanted to say. Okay, good. I just want to make sure that everyone has this file in front of you, because you have to work this out together with me. I've had a lot of people uh, in homework one. I had a lot of people who didn't do homework one, not the way I taught. They did it completely, like pencil and paper method, and that's not what this class is about. And you don't get credit for if you do it like pencil and paper method. And why is that? I posted even every day, um, all these session recordings. I updated it every day, right? And whatever is uh, way past, you can still find it on YouTube, right? It's just a matter of watching that video. I mean, I provided already uh, the main lecture, right, ahead of time in advance. So you must have, and then you study it through the lecture and you study it through the reflection, right? We're doing the reflecting. We're doing the reflection during this collaborate session, and after that, all the collaborate sessions are updated. I mean, the recordings of collaborate sessions are updated. Um, in Blackboard as well as in YouTube. So it's just a matter of watching them. That's studying. That's called studying, and they don't do that at all. And somehow they just follow, read the book or whatever, but look, I've been telling you, the math level of math in this class isn't that high. It's only about sixth grade to eighth grade math at best. Sixth grade to eighth grade math. So there's no point in proving that you can do sixth grade math, right? What the whole point of this class is that you can do this architectural design, right? The structural design of a model that can be replicated over and over and applied universally, right? So that you can avoid solving every problem, one problem at a time, each time, right? That's inefficiency. The reason we are doing this is, to build a model, construct a model, so that it's got a structure, and the structure must be, efficient. There must be an efficiency, right? So it can be, um, and somehow, half half the people, among those who submitted, half the people just did just did it wrong. And that proves only what? That proves that they didn't they didn't attend class. I mean, they looks like, see, I have only five people, excluding myself, five people in this session. And then that means we have 14 people. I've been telling you, 14 people on the roster. 14 people are enrolled in this class. The rest of them are not paying attention at all. They're not participating. They're not studying. And it will serve them, it will only serve them right. It will only serve them what they deserve. Think about it. You don't participate in class, you don't watch the videos that are triple served, right? I'm serving videos, in three ways. Lecture is being served, three ways. Despite all that, if they don't, take advantage of that, then it's their fault. You just, you got to understand, you can't expect to get good, grade when you didn't do the work right, right? You got to do the work right, the right work, you know. The right work means, you know, doing it the way I taught you, right? If it is any different from the way I taught you, then you don't get any credit because you are missing the point if you're not doing it the way I taught you. Okay. All righty. So back here. So okay, let's find, you know, APY. Uh, so it's simply 1 plus, oops, 1 plus APR over M raised to M minus 1. Of course, when, you know, compounding is annual, of course it will always be APR and APY will be the same, right? But now this is the again, you know, from here on, you just need to just drag it down. Oh, something raised to D2. What happened? This is not right. What's going on? Oh, that was not E2, but B. There you go. All right. Okay. So this way, you found this way you found the APY, and we want to check. We want to verify. So how do you check? Now, simple. What is APY? By definition, APY is by definition, it's a that annual interest rate, right? That will take you to this future value, right? Um, by just, you know, annual compounding, right? If it is compounded annually, right? So let's see. Check. We're gonna check. I'm gonna check here. Roll. Okay, so if the APR is like this, think about it. Um, yeah, I'll just leave it. And then by compounding just, you know, once a year, oops, what did I do? We should get the same result. We should get the same result, right? So that means, you know, simply by multiplying, we do this, right? Ah, I don't need to do that because we are just, you know, compounding ones. Okay. So you drag it down and see what happened here. Yeah, it's the same future value, right? And in here you see it's just a uh, single annual, right? Annual compounding, right? Annual, the rate is annual, compounded for 5 years, and that this interest rate will take you to this future value, just compounded annually, right? This interest rate will take you to this, just compounded annually. So that is, APY. Okay, so the check worked, right? And then, so we got to move on to, now we actually have a very, difficult, tough, not difficult, but tough, hold on. Okay, so we have that. Verify that. Next is, so I left this, I deliberately left the row 8 blank because it's going to take some time to get to that point. But if you have already watched the videos already, up to actually up to today, as of today, you should have watched, in there already. Topic 3. We're already in topic 3. So as of today, you should watch, all of this. So everything in the time value of money, you should have already watched. You should have. So, but before I move on, so let's take a look at the rest of the problems. So here, next thing is, okay, I don't know why this was like that, but I don't know why future value is 216, F2. Where is F2? What is F2? Okay. I see. Now think about it. We did LU 12-1, right, as an example, right? So let's put the problem upside down. Or now, if we know, let's make it. This is two. Let's make it $10,000. This is too. The number is too ludicrous. Okay, so let's think about it. If you're going to be 10 years later, you're going to be receiving 10,824, right? You want to receive, right? You want to receive 10,824 10 years from now, okay? And currently the prevailing market interest rate is 6%, and compounding is just once a year. Okay, I don't know why this one is same as F16. I gotta make it equal 3. Okay. So if you want to receive 10,000, if you want to have $10,800 in your bank 10 years from now, and interest rate is 6%, and the compounding is just annual, how much do you need to put into the bank today? Right? So this is the reverse question of compounding. In other words, in compounding, you are trying to find future value. But in this problem, you know the future value, and what you don't know is the principal. So then how do you solve for principal? It's simply, all you need to do is simply think about it. We need to solve for the principal, exactly, I don't know why that, from this formula, right? From this formula, we need to solve this formula for P, right? And that's not a difficult thing. Why? Because I've been telling you over and over, a key to solving any equation is to, key to solving any equation is identifying z equals x times y formula. That structure, z equals x times y structure. And it's not difficult to find, right? By now, everyone should be able to do this. I mean, I don't have to tell. So, so everyone can identify this structure, right? In this formula, everyone can identify this structure, right? You're just very quiet, and that doesn't help. Christopher, are you there? Christopher? Christopher? Looks like Christopher's not there. Hannah? Hannah, are you there, Hannah? Okay, Hannah, thank you. Maricel, are you there? Okay, Hannah, you can lower your hand. Maricel, are you there? Maricel? Why am I doing this if nobody's... Just Hannah is... Mohammed, are you there? Mohammed? Okay, thank you, Mohammed. So 2 people are paying attention. Monique, are you there? Thank you. 3 people, at least. Out of 5, 3 people. 2 are lost. So can any one of you, at least there are 3, can you tell me which one is x in this formula? Can you tell me which one is x in this formula? No one?
Is it the P?
Yes, yes. P, yeah. Who was that?
Mohammed.
Who was that? Mohammed, okay. So Mohammed, you got, 0.25. Yeah, P is x. So solving for x, we know what to do. And so if you want to solve for x, then it's z divided by y. It's the same thing for y, right? Solving for y is also z divided by x. So then, since p is the x, so p is the unknown, what do you need to do? So you'll need to divide. So to find p, you'll need to divide. I think I should do it here because so to find p, it's screaming all over. This is, fv over 1 plus r raised to n. Okay, so in this case, p is called present value, right? Think about it. What that means is that's principal is what that future value is worth today. I mean, in other words, um, if you want to have uh, if you want to have this future value, right? If you want to have this future value, you must have exactly. You want to have this future value, you must have exactly. You must put 10K into the bank today, right? So that's the present value of that future value, right? Also, think about it. If you have this right, if you have something, if you have a bond that's going to mature in 10 years, and in 10 years, it's going to give you 10,800, right? And if someone is asking you to sell you that bond, if someone uh, and if you need cash, right? You can't wait 10 years, you need cash. How much would you sell it for? You would exactly sell it for $10,000. It's not going to be any less than. You're not any less than. You're not going to get, you're not going to sell it for any less than $10,000. Okay? So that's the present value of that bond. So then using that rule, right, we're going to find the present value, which is, future value over 1 plus r, right? Of course, divided by m. In case m is not just 1, in case m is anything other than 1. And this is also structural efficiency. In other words, people who did it wrong, people who did it not in the way I taught, they don't think about this. They just simply because it is annual compounding, it is not necessary. I mean, it doesn't make any difference. So they don't do this. If they don't do this, then they will have, when they do another problem, they cannot just copy and paste it, right? Each problem will have to be done differently, right? And then they manually enter, manually input 360 or 365, whatever is, that's, I've been telling you, that's called hard coding. And you don't do the hard coding because it's stupid, because it cannot, if you do hard coding, it cannot be flexible. It cannot be used in other situations, right? So then you raise it to, again, times n. You can do it like this, or you can do it with one more column, two more columns, right? Then it becomes a lot easier, right? Hit enter. What happened? F17, 1 plus C17 divided by E17. APR by N raised to D17 over. Something's not right. Why is it? There's got to be. Huh. Oh, that's 6%. It has to be. Difference is. No wonder. Uh-huh. You got to have, the original was 8%. Original problem was 8%. Then why is it, again, giving me all this? Oh, that's 1 year. That was 1 year. Okay. Of course, it has to, because I'm simply flipping this, the same scenario, right? It has to match, everything has to match, right? The input data must match. And this, if you just drag it up, yeah, when compounding is quarterly, right? You do it. Also, let's do this. Let's do it like this. Let me copy this. Paste it here. And in 2 columns. Okay. And then that's not right. It's got a point 2. Okay. So what are these columns? They are columns for R and N. So R, that's, we know APR divided by N. I give it percentage. Don't forget to use, at least, don't leave it like this. I've been telling you, you got to use at least 2 to 3 decimal places by default. Okay. And then, is APR 7%? No, 8%, right? Why is it? So, because it's pointing to, and this one is, N is, time is just, everything is all pointing to the wrong cell. That's why. Okay. And I've been telling you there's a rule for highlight, and I've been emphasizing this over and over. And people who don't pay attention to class, I mean, they don't even participate in class, and then don't even watch the videos, lecture videos. How do they? I don't understand how they think they can manage to pass this class. But in the videos I've been explaining, and in every collaborate session I've been explaining. Yellow highlight is reserved for only for the primary solution cell. Intermediate calculations need to be highlighted by some light color, but I prefer like military khaki or drab, or olive green, olive, because this is light, because when you actually print it out, on and black and white printer on a black and white printer, this will come out as dark. Everything will come out as dark, but the lighter backgrounds will come out light. And if it is dark, you can't see. I'm not sure if yellow was, I don't think yellow. Yellow is bright on the computer screen. When it is printed out, it's not that bad. It's not that dark, even on black and white. So here, we have taken care of R and N's separately in separate columns, and then our formula becomes easier, much easier, right? So it's simply FV over 1 plus R raised to N. Okay. And we get to the principle in the original problem, and I told you this is called also present value, right? Present value. Now everyone also tried this out. Everyone did this. Now, our next question is, right? So when we have see how many, these are all variables, right? Aren't they? APR, time, right? Future value. I mean, if you're solving for future value, right? Principal, APR, time, those are variables. Also, M is a variable as well, right? But M is generally not. M is given. Nobody is trying to. It's not the unknown. M is not the unknown because M is compounding frequency is given, right? It's basically exogenous to the problem. So I don't know if how many of you are really listening now, but I hope. And you all got your graded homework back, right? At least those who submitted homework 1, you got your graded homework back, and your score. Of course, some people were even asking, where's the final score? This is just homework. I know what they meant by final, but the point is, okay. All right. Well, what was I talking about? Yeah. Um, so basically, look at the formula. If you look at the formula, right? Um, this is the if you're solving for, if this is the unknown, if the future value is the unknown, right? Future value is the unknown. All the other variables must be known, right? All the other variables. In other words, P is known, R is known, N is known, right? That way we can solve for, you know, future value, right? Uh, I don't know what was supposed. And if principal is the unknown, right? To solve for principal, right? Future value must be known, R must be known, N must be known, right? Um, and the process compound and this process to find present value, I already said, is called discounting. And discounting is, so discounting and compounding are reverse processes of each other. They're a reverse process of each other, right? Now, our next question, and since we have four variables, right, each variable can uh, be an unknown. In other words, there can be a problem such as, now let's think about it. Let me delete all this. Think about it. You want to have $30,000 in 5 years, right? You want to have $30,000 in 5 years, right? And then you have $10,000 today. So you put $10,000 in the bank. Um, so what will be the interest rate? What kind of interest rate will take you to $30,000? I mean, what should be the interest rate to have $30,000 5 years from now? And for now, we are assuming that uh, M is just one. So I'm not putting any one there because when M is one, right? Uh, Later we will incorporate one, but for now, just to make it easier to think. Now think about it. How do we solve for APR? So it's a question of solving for, so what should I do? Because we don't have much time, uh, let me show you how it is derived, right? So, because this is the formula, right? Future. And I told you, principal is also present value, right? It's called the present value. 1 plus r raised to n. And here, our unknown is this, right? This is our unknown, right? This is our unknown. And everything else is known. Future value is known. Present value is known, or principal is known, n is known. Then, how do you solve for r? First of all, um, there's no way you can isolate just r because um, say if suppose n is 1, suppose if n is 1, right, then it is easy. If n is 1, it's simply, think about it. We cannot directly isolate r, so we will have to first, isolate whatever we can, and we can isolate first this term, right? And we cannot isolate r from that because it is inside a parenthesis and it is locked by this exponent, right? Does everyone understand what I'm saying? Any questions so far? Any question? Okay, so so if n is 1, then this will be simple, right? You can it simply becomes 1 plus r if n is 1. But then it's not the case, right? N is not 1, so we still, we're still, stuck here. So to then, the point is we need to lose n, right? We need to open the exponent. How do you open? How do you lose the exponent? So here we need to think about, we need to think about the again. I explained this all in my videos, and it's really it's not very effective, right? When I cannot see or hear any response from anybody, it's really hard to just, speak to an empty hollow, empty space. But anyway, let's think about, we all know x squared, right, can be how do we turn this into x? Through what process can this become x? Anybody? Christopher, are you there, Christopher? Hannah, are you there?
I'm here.
Okay, Hannah, can you tell me through what process we can turn x squared into x?
I'm not sure, but maybe x raised to 2 minus x raised to 2.
X raised to
is it square root, Professor?
Yeah, yes, of course. You take the square root. In other words, this process to turn x squared to x is to take the square root of x squared. In other words, what's the root, right, of the square term? That's why it is called square root, right? And taking square root, and who was that? Who said that?
It was me, Mohammed.
Okay, Mohammed. So Mohammed, you get, another 0.25. But taking square root is, another expression for square root is why is it going all the way up always like that? Okay, let me bring it here. Another notation, another expression for square root is something raised to half power, right? In this case, we are taking the square root of the x squared, right? So we will lose, we will lose the exponent. But think about it. This is square root of x, right? We don't know what it is. And another way of writing it is something raised to half power. Okay? And let's do a little, refresher, right? Refresher. So this may be okay. Here's the so we all know x squared. If x squared equals y, right? So it's like 2 squared equals 4, right? Of course, 2 squared equals 4. We all know that. And if you take the so if you take the square root of 2 squared or 4, right? It will be 2, right? So taking the square root, you normally don't think about just this, putting 2 there, but originally there's 2 there. Originally, they just omit it when we are referring to the square root. But there has to be 2 there to represent square root. Why? Because there's a cubic root, there's 4th root, 5th root, 6th root, right? Think about it. There's only x squared. There can be x cubed, x to the 4th power, x to the 5th power, x to the 7th power, x to the nth power, right? So if you are taking the root of the x cubed, then that's called cubic root, or the 3rd root, or 3rd radical, right? Radical meaning root, right? So if we represent a cubic root, right, then we have to put 3 there, right? And as I said, another notation, another expression for square root is something raised to half power. Okay. Now that it requires other, another thing. We all know. What do you know? I mean, what is x raised to -1? What is x raised to -1? Anybody? What is x raised to -1? Can anybody tell me? Monique, are you there, Monique? Monique? If you just type in there, in the chat box, I can't see. When I'm looking at this Excel file. So while I'm looking at this, while I'm, also sharing this screen, I cannot. This is what I see, not the not the blackboard. So please speak up. And you raised your hand, so can you speak?
Professor. Yes, sorry.
And you seem very tired. You sound very. Are you
Sorry.
sleeping?
No, Professor. I was sick last week and I'm still recovering.
Oh, okay. Monique, so what is x raised to -1?
Is it x divided by 1?
X divided by 1. If you divide x by 1, it's just x.
Right.
Think about what you're saying. X divided by 1, that's 1. That's x.
Right.
So that's not it. I mean, what is it then? Hannah.
Even when you have a negative exponent, isn't it the reverse of the base?
What's that?
When you have a negative exponent, you have the inverse of the base.
Yes, yes. It's the inverse. Then that's not x divided by 1. That's not x over 1. That's what is that then? You know what? You know it's the inverse, right? So what is it then?
Oh, sorry, it's 1 divided by x.
Yeah, it's 1 over x. Yes.
Yeah, sorry, I said the other way around. Sorry.
So you got to pay attention. People, people just habitually say things, that they don't mean, things like, when you say, because is 1 divided by x, or, there are two ways you can say this. Is 1 divided by x, or x divided into, let's not get to that, because that will only only take our conversation, deviate, straight. They will only make our conversation straight from the path, go astray from our path. Yeah, and so yeah, we know 10 to 1 is just itself, right? Something raised to 1 is just itself, right? But something raised to -1 is the reciprocal. 1 over 10. Also, then what is, and we know 100 squared, 10 squared, 10 squared is 100, right? That goes without saying. We don't have to, but then what is 10 raised to -2? It should be easy to answer now. What is, 10 raised to -2? Say that again. Who said that?
Mohammed. 10 equals
Yeah,
1/2.
1/2? This is 1/2? 10 raised to -2? How can it be 1/2? 1/2 is 1 over 2. This
I
is
mean 1 over
10
5.
raised
1 over 5.
1 over 5?
Because
10.
if you divide it on the other side.
You what?
Oh, never mind. Never mind.
It's 10 raised to -2. And what did Amorim Monique say a while ago? If x raised to, raising something to -1 is the reciprocal, right? But then reciprocal, then you are raising it. So 10 to -1 was the reciprocal, 1 over 10. Then 10 raised to -2 should be what?
2/10.
2/10? How can just... Come on. 2/10? 10 squared is 2 times 10? Is 10 squared 2 times 10? Check your, please, inspect your reasoning. Check your reasoning. I mean, how can that be logical? If raising something to -1 is the reciprocal, raising something to -2 is also reciprocal. Anything raised to negative number is a reciprocal. But so this is what? What should this be? Hannah, can you tell me what this is? 10 raised to -2? Are you there, Hannah? Oh, Hannah's. Monique, you raised your hand. Monique, you raised your hand. Can you tell me what? Hannah, are you there? Hannah, can you hear me? No, she's lost. The connection is lost. Okay, Monique, you raised your hand a while ago. Can you answer this? What's 10 to -2? Oh, this is you have second homework coming up, and you can't even do this. This is just...
Isn't 20%? Yes, 0.2.
20%? What? 20% is 0.2 times 10. That's 20%. I mean, 1.2 times 1, that's 20%. I mean, we're not even... 10 squared is what? What is 10 squared? I don't know. I mean, it would be easier just to fail you.
It equals 1/100.
1/100, yes. Now you're thinking. It is 1/10 squared. Think about it. It's the reciprocal, so it's 1/10 squared. Right? And so 1/10 squared is, of course, 1/100. Okay? That's the negative power, right? Negative exponent. Then what about, fraction, right? Exponent in fraction is actually the root of the power, right? So 10 raised to half is square root of 10, of course, right? Square root of 10. Okay. 10 raised to 1/3 is the third root of 10. We don't know what the third... You can't easily calculate, square root or cubic root of 10. Of course, we have calculator for that. You don't have to. You just need to have that logic in your brain, right? But it will be easier to calculate if it is 100 raised to half power. Can anybody tell me what is 100 raised to half power? Well, that's the square root of 100. Isn't it right? That's the square root of 100. So what is it? Can anyone tell me? Hannah, are you there? Hannah? What's the connection? So Hannah's not here. Christopher. Christopher, are you there? And you're not there. Hannah, are you there? Now you're back. Hannah, are you there?
Yeah, I'm here.
Hannah?
I'm sorry, my internet is not working so well today.
Okay, Hannah.
Yeah.
So tell me. I mean, it would be easier. I mean, we know. I don't know if you heard, if you followed so far. Anything raised to half power, that's the square root. Raised to 1/3, that's 1/3. That's the cubic root. It's not easy to tell what is the square root of 10 or cubic root of 10. You cannot mentally calculate it, but that's what the calculators are for. We don't have to calculate. We just need to understand the logic of it, right? But at least this is easy. Half power of 100, half power, 100 raised to half, 100 raised to half, which is square root of 100, 100. Isn't it easy to find mentally? Calculate this. What is the square root of 100?
10.
10, of course. Was it Hannah? Was it Hannah?
That was me, Mohammed.
Okay, Mohammed. What happened to Hannah? So I'll give you 0.25. You stole it from Hannah, but I'm not sure if Hannah is still connected. I think, yeah, Hannah is still connected.
Yeah, I'm here.
All right.
I'm here.
Okay, so don't let someone steal your point, okay? When I asked you this question to you, okay, and we can tell also what's the cubic root of 1,000? What's the cubic root of 1,000? In other words, right? Hannah, cubic root, or 1,000 raised to the third power. What is it? Did someone type into the chat box? But I told you there, I can't see. You must speak. Hannah, can you tell me? Can you give me the answer? What's the?
I'm not sure, but it's 333.
333? What are you talking about? Huh? Are you dividing something by? Are you dividing? This is not division. I'm shocked. Okay, this is exponent.
Is it 100?
No. How can it be 100? I mean, something raised to third power. I mean, 1,000 is what? How do you get to 1,000? It's 10 times 10 times 10. Isn't that right? 10 times 10 times 10. That's 10 to the third. 10 to the third power. 10 cubed. That's 1,000. How can you think about division here? We're talking about exponent. You don't know what exponent is? Huh? Raising to power. Look, 100 is the cubic root of 1,000,000. Isn't it right? 100 is the cubic root of 1,000,000, because think about it, just 100 times 100 times 100, 100 to the third power, that's 1,000,000. Right? I don't know how this can. You have the second homework 2 due. That's tomorrow, and it's just you don't even have the 8th grade math. How can I take you to Look, so the point is, this is the notation. I mean, something raised to, I don't know where to write it anymore. Something raised to half power is the square root, right? That's another expression, right? I keep writing this so many times. And I don't understand. I mean, if you have watched these videos already, you must have questions, and nobody's asking questions. I've been also, I've been telling you, this is not where we are now, right? This topic two, this is already over. And this is topic 3 is where you should be today. This is where you should be today. Right? You should be watching these today. And you are, Hannah, did you watch all these videos? These are already gone. They are already more than 5 days old. They are no longer visible. But did you watch these videos, Hannah? Did you watch them? Tell me. Don't just stay quiet. Did you watch these videos? I just want to check if... Come on, I'm asking you. It's just yes or no. Did you watch these videos?
No, but do you hear me? How,
Yeah, but what do you mean? No, they were. Do you see? You should, huh? It was last available. These single cash flow model, future value, part 1, part 2, part 3. They were last available on July 27th. That means they were available. They were visible from July 22nd, and you should have watched them by July 27th. And this was last available on July 31st. That means from July 23rd, July 26th, they were available. Somebody was saying something. Okay, Hannah, your microphone is on. So but your connection is very bad, very poor. Everybody else, did you guys watch those videos on time? Okay, Manik, you did. I would take it as yes. How about Mohammed? Okay, Christopher, finally, you've been away for a long time, Christopher. But I would take it as yes, that you guys watch those videos on time, because you have to watch them while they are still there. And then, so already these videos are gone, right? You cannot, they can be found on YouTube, right? But they are not in Business 210. I gave you 2 playlists. They are in other playlists. They are in FNB 100 playlist. And I told you they are cross-listed, right? These are still visible, but they're I guess they will be no longer after today. And someone was trying to say something. Was someone saying something? This is, even if you're saying something, no, it was just very dim, very faint, and choppy, right? Maybe it's due to the connection, but it's very choppy. You should enunciate because it's choppy. You understand? When you speak, please enunciate. Right? Speak clearly. Oh, that's not chat. Oh, I should type it in. I can't type it in. Because your voices are either very dim, very faint, breaking up, or very choppy. Okay? Choppy, not chippy. Now it feels like I'm fighting I'm fighting a hopeless battle. I mean, this feels like a lost cause, because nobody, hardly anybody understands anything. I mean, only one or two people. Very, you know. So don't type in there. I can't see, and it takes time. If I switch between, this and okay, you can't. All righty. Again, please understand that what we do in the collaborate session is not class. This is not the lecture. Okay, this is only reflection of the lecture. And if the lecture is delivered by the video, right, pre-recorded video, so you should take advantage of this time. You should utilize this time to ask questions that couldn't have been answered during while watching the video. Understand? It takes so much time to reteach everything when you don't even have this basic math. When you don't even know what exponent is, when you don't even know this basic algebra, we can't move ahead at all. We can't make any progress when you don't even have this basic algebra, right? This is not, I cannot reteach everything. And I'm already bogged down. This class is already held for 1 hour, 30 minutes in basic algebra. And nobody's even asking anything. If you don't have that, basic algebra, while watching that, pre-recorded video, right? You must have had questions, if you don't understand, if you don't know algebra. then you should ask, you should do that here at this time. So, okay. Anyway, the point is, you can express any, any root, right, by raising to 1 over n, right? That's, nth root of x. So the question was, Hannah didn't even, third root of 1000 is 10, isn't it right? Everyone, it's 10 times 10 times 10, right?
Yes.
Yeah. This is something you know. So, but also 10,000, right? The fourth radical, or 1/4, 10,000 raised to 1/4, which is the fourth radical. I can't write this, every time because it takes so much time, and it's the fourth root, right? It's 10. Keep doing it like this. We can do 1 million is sixth root, right? I mean, 10, because 10 to the sixth is 1 million, right? And think about it. We can all rewrite this as, this is 10 to the third power, right? Because 1000 is 10 to the third power raised to 1/3. Isn't that the same thing? Right? This is 10 to the fourth raised to 1/4. Right? Isn't it the same thing? Mm-hmm. So here we come to a general rule. The general rule is, what did we do here? When we raised 10 to nth power, right? 10 raised to nth power, and then if you again raise it to 1 over n, what you're doing is ten raised to n times 1 over n. Isn't it right? And think about it. These two will cancel out. So then it becomes just 10 raised to 1. Okay, so what do you see here? What can you see here? These are one of the rules. These are one of the rules of the exponent, and I don't. Okay, let's take a look at this. Anything raised to 0 is 1, right? Some people, and if you don't know this yet, it's a disaster. I'm sorry that this is very basic algebra, and if you don't know that yet, it's you really need to take, math remedial, right? I mean, this class requires at least math 059, I believe. Math, the remedial, the level of remedial is 056 or 050, at least, or a math 206. But then, officially, we cannot have it as prerequisite officially because uh, uh, and here, negative exponent, something raised to negative power is 1 over, it's the reciprocal, and the product of powers. In other words, so a raised to b times a raised to c, when the base is the same, then you simply add those exponents. So for example, a simple example, let's think about this. So 10 squared times 10 cubed, what is this? Mohammed, what is 10 squared times 10 cubed? Mohammed. Are you there, Mohammed?
Yes, I'm here. It's 10 to the 5th.
10 to the 5th. But what is 10 to the 5th? How did you
So
10?
so 10, so the base will be 10, and then you just add the
No, no,
power.
no, 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 no. Don't get there. Don't go there yet, because
Yeah.
that's just doing it without thinking. But first, let's use common sense. What is 10 squared?
It's 100.
100. Okay, yeah.
Look, and then times
And
1,000.
times, what is 10 to the third?
1,000.
1,000. So think about it. 100 times 1,000 is, what is it? 100 times 1,000. Come on, isn't this 100 times 1,000? What does that mean? There are 100 of them. 100 of what?
100,000.
Yeah, it's 100,000. Why is it so difficult? I'm not even using any complex number. I'm using only 1 and zeros. When you do that, you only, add these zeros, right? It's 100,000. I mean, literally, that's what it means. Isn't that right?
Yeah.
100 times 1,000 is literally there are 100 of them, right? But then 100,000 is exactly what? If you express it in terms of 10 and power, it's, what is it? 100,000 is
10 to the 5th.
10 to the 5th, right? Because 5 zeros, right? 10 times 10 times 10 times 10 times. You do that 5 times, right? 10 to the 5th. So isn't it exactly what that rule is saying? When we are both, we are dealing with, something with the same base, right? And if you add them, that's exactly 10 to the 5th, right? And then next rule, quotient of powers, yeah, same base, a to the b over a to the c, then a to b minus c. Okay, of course, base shouldn't be 0. If base is 0, it all collapses, nothing. And then next rule, product, right? This is when, the exponents are the same, but the bases are different. But we're not gonna be we're gonna come back to that later because it's not important at this point. Power of power. Power of power. A raised to B raised to C is A raised to B times C. But isn't that what we just did? Think about it. I mean, with this, isn't that what we just did, right? For example, 10 raised to n raised to 1 over n, right? So in other words, let's try this. 10 squared raised to third. So what is this? Monique? Are you there, Monique? Monique? Did I lose Monique? Yes. Monique, if you can hear me. Mohammed, okay, Mohammed, you raised your hand.
Yeah.
Mohammed,
You want me to say
okay.
it?
Yeah, you can
Yeah.
you
So
can
it's
answer
gonna be,
these.
so since it's out of the bracket, so you multiply the two powers first.
No, don't go there yet. Don't go there yet.
So it will be
We'll just
100 inside the brackets, open parentheses, and then to the third.
Yeah, 100 to the third. And what is the 100 to the third power?
It's
What
1
is the
million.
100 to the, huh?
1 million.
1 million, yes, because it's 100 times 100 times 100. It's 1 million. And we all know 1 million is what? 1 million is
10 to the 6, since it's
10 to
six
the
zero.
sixth. Yes, it's 10 to the sixth, right? It's 10 to the sixth. Okay, so you're getting another 0.25 for that. Yeah, and then think about it. 10. What we did was exactly 10 squared. 100 is 10 squared, and that was raised to that was again raised to the third power. So you multiply those exponents, then it's 10 to the sixth power, right? Which is exactly, oh, come on. That's so hard. Which is exactly 1 million, right? Which is exactly 1 million, right? So this is what, and the next rule, I'm not gonna, there is, rational exponent property, when the base, we know very well that by now, raising to uh, a fraction is the root, right? So a raised to c over b is actually, a to the c, right? A raised to c, and it's the bth radical. Bth radical. That sounds, it's like, nth radical of that, a to the c. But what we need here is this, power of power, right? This power of power. So then, why is it important? It's important because that will help us lose that exponent. In other words, so here we were stuck here, right? Isn't it right? We were stuck here. Let me the whole thing. I cannot copy the whole thing, so I will just. So we need to solve for n, but we are stuck there. First, we had to isolate, right? We divide both sides by PV, so then we isolate. Okay, and the thing is, because of n, we cannot open up this this term, right? So then we know what to do, because if we raise this, if we take the nth radical of this, if we raise this, the right-hand side, in other words, if we raise the right-hand side, I will just call it, because it takes too much time to write, I will use, right, the dot in the bracket. So dot in the bracket is basically, you know, the thing in the bracket, right? The thing in the, and then the problem is you can't just do that on the right, in the right-hand side, because remember, there's an equal sign. That means it's the equation, right? It's the equation. And the equation means whatever you do to one side, you must do the same thing to the other side as well. Otherwise, this equal won't hold. I mean, equal is a very important thing, because when there's an equal sign in between, what does that mean? When there is an equal sign in between, oh, come on. That means, you know, it's like a balance, right? It's like a, you know, scale on balance, right? So if you, that's what equal means. So if something happens to the right-hand side, it must also happen in the left-hand side. So only when you take the nth radical, then the equal will hold. Okay? Again. And then the thing in the parenthesis will, you know, we're gonna write it later. But now, because we know the power of power, right, rule, it's the thing in the bracket raised to n times 1 over n. These two will cancel out. It will become just 1, right? Now then our problem is a lot easier, right? Our problem is a lot easier, because now it is, because we don't have any exponent, we have what freed up. We have freed up the right-hand side. So right-hand side is 1 plus r now. But the left-hand side is still the thing in the bracket raised to 1. So, and what is our unknown? What are we trying to find? This is our unknown. R is the rate, is our unknown. Remember, the question was, you have just $10,000 now, and you want to put it in the bank, and you want to grow it to 30,000 in 5 years. So question is then, what should be the interest rate? Isn't it right? So our question is R. So then, that's why we did this, because to solve this equation for R, we had to isolate R, but there was no way we can isolate that R. So what did we do? We had to isolate R. We have to first lose N. We have to get rid of N. And how do we get rid of N? We have to take the nth radical of that right-hand side, right? But because it's an equation, you have to do whatever you do to one side, you have to do on both. So that way, the left-hand side is now nth radical, 1 over n. Right-hand side is freed up. And so since we want to know R, we're solving for R only, right? We isolate R. To isolate R, what do you need to do? You must subtract 1 from both sides, right? So this 1 goes to the left-hand side as -1, and the left-hand side is FV over PV raised to 1 over N, right? Does that make sense? Everyone, does that make sense?
Yeah.
Yes.
Okay, thank you. I heard 2 people. Was it Mohammed and Hannah? Right?
Yeah.
Was it Mohammed and Hannah? Okay,
Yeah.
thank you, Hannah. I thought I lost you. I thought I lost you because of your internet. All right, Monique, you got that too, right? Monique? I didn't hear you, Monique. Christopher, are you there, Christopher? All right, I think that ding must be Christopher. Can you speak, Christopher? I will have to assume Christopher was also following. So this is the formula. This is why. This is how that formula was derived. Okay, I'm not, because it would be easy. Some people think some professors because it's really hard to teach this way, and when you don't have a strong math background, I have to reteach. You have to reteach everything from the scratch, and then it's absolutely, there's no time for that. So some people just skip everything and just textbooks, finance textbooks, they just give you this, right? Without explaining, without any explanation, they just give you only the end result. But then you just memorize without understanding why. But when you understand why the formula is like this and how it was derived step by step, right? Then once you practice this a couple of times, you won't forget, right? You don't have to memorize anything. So let's do this problem. So again, in this problem, we're trying to find R, right? We're solving for R. So what do? And it's just annual compounding. So there's nothing. I mean, no M. Ignore M. You can ignore M. So all you need to do is simply. So this T is N because when compounding is annual, when M is 1, T is exactly N. APR is exactly R, right? Because M is 1. So FV over PV, right, raised to 1 over, it said, N, but, T is N, and you cannot click it in. You cannot use the mouse to click it in because this formula is, covering it, right? It's overlapping that cell. So I'll have to type in manually, right? I will have to manually enter D25 because there's no other way. Because it is, the formula is, hanging over that cell. So you enter. Now, we got that, right? We got that. So this is how you solve for rate. Okay, this is the formula for rate, and you can check. You can simply check. So P times. Let's try that. P times 1 plus R raised to n. It should give you exactly 30,000. Exactly 30,000, right? It checks out, right? It checks out. Now, let's the same. Now let's put in compounding frequency. Now I'm gonna use the same. I'm gonna use the same setup, right? I'm gonna use the same setup, and then we'll see. Oh, okay. Now everyone understands why I'm doing this, because there's n, and a compounding frequency is basically the same scenario, but previously it was annual compounding. Now it is quarterly compounding. If it is quarterly compounding, then we must find R, the periodic rate. We cannot find APR first because compounding is quarterly. We got to find quarterly rate. That goes without saying. Then, okay, so what do we do? All we need to do is simply, we can make adjustment inside the formula too, but this way it is easier, right? The formula is simpler. Simply raise it to 1 over n, and the n is in G. I'll have to type it in manually. G32 and minus 1. There you go. So what is that? The quarterly rate, periodic rate, is 5.65. We know, of course, since compounding is quarterly, annual over 5 years, there will be 20 compoundings, right? Over 5 years, 20 compoundings. So we got that. So now, if quarterly rate is 5.65, can anyone tell me how to find the APR? The quarterly rate is something. Then how do you convert quarterly rate into annual rate? Anyone? Hannah, can you help me out here, Hannah? Huh?
Yeah.
Yeah. Okay, so Hannah.
Equal.
Uh-huh.
Open parentheses.
You don't need to open parentheses here. Let's say open parentheses.
H32.
A32.
H32.
H32. H32? No, why? We're just trying to find. Okay, try. Go ahead. H32
divided by BH32,
B32. Okay.
closed parentheses,
Mm-hmm. Mm-hmm.
raised to,
Mm-hmm.
open parentheses,
Mm-hmm.
1,
1. Why? Okay, but this is I'm having a okay. Go ahead.
divided by
Divided by. Mm-hmm.
yeah, the D32,
D. D32. Did you say D?
D32.
Now, look. Yeah, that's fine. I mean, you can. Yeah. In this case, yeah, D32 because we are finding annual, right? Yeah, D32
minus 1.
minus 1. But look, this is just this is just this. Uh, Look, this is not right. This is wrong. Why? Because you're not considering. You did it like just there's an annual compounding. We this look we this is quarterly compounding, right? It's not annual compounding. First of all, how many compoundings happen over 5 years? What you did was just this. But that's when compounding is annual. Here, compounding is quarterly. And if the compounding is quarterly, there are annually 4 compoundings, there are 20 compoundings over 5 years. Why do you think I got this? Right? Look, I did it like this. So we found the rate already. Isn't it right? Do you understand?
Yeah.
We found the rate already, but this rate is quarterly rate. Every quarter, right? It's the periodic rate. So then, because we already found the quarterly rate, then APR is what? Annual rate should be what? Isn't it simply quarterly rate times periodic rate times N? You understand? Hannah, do you understand? Did you see
Yeah, yeah,
something?
yeah.
Because think about it. Look, when we had like here, compounding frequency is quarterly, right? Uh, Annual, semi-annual, quarterly, daily. And under certain circumstances, what did we do? We found the quarterly rates. I mean, we found the periodic rates because that's what is being actually applied every compounding period, right? And also, how many over 1 year, right? Quarterly compounding. How many compoundings actually happen? 4 times, right? In this example, over 8 years, semi-annual. So every 6 months, right? Every 6 months, 1.5% is the periodic rate. And over 8 years, how many compoundings happen? 8 times 2, right? 16, right? So we found periodic rate by dividing APR by N. So if we got periodic rate, getting back to APR is simply this times M times this, M times R, right? Why is it so difficult? Huh? That's not, it's only a very logical, and it's not very complex logic. So this way you do it like this, right? But again, then you might wonder, oh, okay, so what if I do it, and I've been telling you, you don't, I prefer this way because that way the formula is simpler. It doesn't have, but if you, let's say we have, in this same problem, compounding frequency is 4. I don't know. Okay. That was a check, right? Where did this? Suppose compounding frequency is 4, and you're not doing it this way. Okay. And in your in the homework, graded homework, I said, you know, put, you know, borderline around it, right? Thick borderline. So if you're not, you know, adding additional columns for pure R and N, then how would you do it? I will do basically it's the same thing. This divided by this, but then it's going to be 1 over, right? T times M. T is, you know, 5, so that is in G. What is D? 27 times E27, and you gotta put these in parentheses, otherwise them in parentheses. Otherwise, you know, it will be just done linearly, and then being a linear person, just thinking, being a linear thinking person is a very, you know, that's not good. It's a simple-minded person. Simple-mindedness is not bad. A simple life, simple-minded person, but will never amount to anything. You should be able to think in structurally. Okay, and then there you go. Then we'll give you exactly this. In other words, why? Because I make, you know, I gave it n. N is not, look, t is not n, right? T is not n when m is greater than 1. If m is greater than 1, n is always t times n. Of course, when even if m is 1, still n is t times n, but there's no difference. 5 times 1 is still 5, right? Now, so everyone understand? Does everyone understand? What, you know, tomorrow. Okay, so that's it for today. Please understand, this is only reflection of the past materials. This is not the current topic we're in. You must be caught up all the way to today's materials. Okay, let's stop.